Welcome back. Welcome to this section on threads. Multi-threading is one of the most important programming concepts. In this video, we'll write a simple program and try and understand why we need threads. Let's get started with a simple project. Right, as usual, let's create a new Java project. I'll call this threads, or you can call this multi-threading. Let's call this multi-threading, and you can click finish. When you click finish, you can create a new project, actually new class. So let's go ahead and create a class. I'll call this thread basics runner. I'll add in a main method and finish. So we have a main method also present in here. Let's say there are three tasks that we are doing. Task 1, and let's say there is a task 2 and there is a task 3. We'll just have simple code to represent what these tasks are doing, right? So I'll say for int I, let's say task 1 for now is just looping around. So int I is equal to 101, I less than equal to 199, I plus plus. So it prints from 101 to 199. And what does it do? It just prints out the number. I'll use system.out.print and I'll use I plus a space. Okay, let's say the remaining tasks are also doing something of the same kind. So let's say this is running from 201 to 299 and this is running from 301 to 399, right? So what would happen when I run this? You'd see that each one of these tasks would run one after the other. Now let's go in here and let's say over here system.out.print, I'll say /n to print the new line and task 1 done, right? So task 1 is done and here task 2 is done and over here task 3 is done, and this last thing is the completion of the main. So main method is done, right? So the main method completed execution. So when we run this, we will be able to see everything going in, right? So you have task 1 that's completed, task 2 is completed, 201 to something, and task 3 is done, and you have main done. Let me just remove the spaces in here. Cool. Okay, right, this is typical programming. What is happening is all the things in the task 1 are done, and after that task 2 and after that task 3, right? This is normal programming stuff, right? Until now whatever code that we wrote runs after the execution of this line, we would go into the next line. So inside a method, first these lines are executed, then the next ones, and then the next ones, and then the next ones. Over here we have three different tasks, right? So task 1, task 2, task 3. Typically in a lot of scenarios you might have situations where task 1, task 2 and task 3 are independent of each other, and some of these tasks might be dependent on external services. Probably you are depending on IO and a lot of that kind of stuff. So during the execution of this task, your CPU will not be fully utilized, but even then the CPU has only one task to execute. So what it would do, it would keep waiting. So even though we can execute task 2 in parallel with task 1, the CPU does not know that. So what it would do, it would keep waiting. Threads allow you to run all these tasks in parallel. So you can have one thread running this code, another thread running this code, and another thread running this code. So all these three tasks can be run in parallel. Parallelism, you can actually increase the utilization of your CPU, because while it waits for data from an external service or a database, it can keep processing the instructions from the other tasks. In the next step, we would start with creating a thread and try and parallelize task 1. I'll see you in the next step. Welcome back. In the previous step, we understood the need for multi-threading? Why do we need to create threads? Now let's start with creating a few threads. At the basic level, there are two ways of creating threads. One is by extending a class called thread. The other one is by implementing an interface called Runnable. In this step, we will focus on extending the thread and creating an instance of the thread class. So what I would want to do is I would want to do this in a thread. How do I do that? I'll call this task1. So I'll say class task1. I'll say task1 extends thread. And in the thread, you need to implement a method. The exact signature of the method should be public void run. So this is something which you need to remember. The signature should exactly match this. This is the exact signature that you need to have. Inside this, you can write the code for your specific task. So now I can go here and do this. Right? So I'm copying the code of task1 into a thread. So into the thread, I've copied task1, done, and this loops and prints this stuff. How do I make the task run? So how do I execute this task in parallel? How do I create a thread for it and run this code in parallel? Let's see that right now. Over here, we would want to create a task, right? So the way I can create that is by saying task1, let's create a new instance of the task1 class. Once you create a new instance of the task1 class, the way you can kick it off is by saying task1 dot run. That's all. So task1 dot run. And to make it much more clearer, what I'll do is I'll add another system.print at the start, task1 started, right? So this is once the run method gets executed, it would start the print method, it would print this, and then task1 done. That's what is printed. The most important thing is I called the run method in here. That's not the method that needs to be called. I wanted to clearly tell you that it's the start method. So a lot of beginning programmers start calling it as task1.run. Task1.run will not really run it in parallel. If I do task1.run, what would happen is it would be executed like a typical method. It will not be executed like a thread. So if I do task1.run, what would be happening? You'd see that task1 started, task1 completed. Then you can see that task 2 is started 201 and task 2 is done. Task 3 has started and task 3 is completed. So this is typical execution, right? If I really want to kick off task 1 as a thread, I should say start. And let's run this right now. Aha. One of the important things you would have started noticing in here is task 1 started, and you see some of the things from task 2 coming and printed in here. So task 201, 202, 204. So not just the things about the task 1. So task 1, we are printing, what is task 1 doing? 101 to 199, right? So it's not just the task 1, but even the task 2 code has started executing even before the task has completed execution. To make this even more clearer, what I'll do is say task 2 kicked off. So task 2 is going to be kicked off right now. So let's put another statement in here saying task 1 kicked off, here task 2 kicked off, and over here I'll put another statement saying task 3 kicked off, right? Let's run this right now. You can see is that task 1 is kicked off, and inside the thread we print task 1 started, and even before the task 1 did any processing, you see that the task 2 was kicked off. So what is happening in here is this code which is present in here is running in parallel with this code. As soon as I said task1.start, this code started running in parallel with the other piece of code. That's what you would see, right? Task 1 started, and you can see 101, 102. That's cool. And after 155, you can see that task 2 is kicked off, And after that, you can see some of the task 2 things in parallel to task 1 things. So if you can see here, it's 210, 209, 208, and all that is running in parallel. So task 1 and task 2 are running in parallel with each other. In this step, we looked at how to kick off a thread. We created a new thread by extending the thread class, and we implemented a public void run method. The way we ran the thread was by saying task 1, creating an instance of the task 1 and saying task1.start. And this kicked off the thread, and we saw that this code was running in parallel with this code. I would recommend you to try and run this program a few times and look at the output and try to see where what is getting kicked off from. I'll see you in the next step where we would try and parallelize even task 2. Until then, bye-bye. Welcome back. In the previous step, we extended the thread class and created a class called task1, and we kicked it off. Right. In this step, we would want to kick off task 2 as a thread as well. How do we do that? In this step, we would take the approach of implementing the runnable interface. Right. So class task2 implements runnable. That's what we would want to use. And as soon as I do this, it would say, okay, implement a method. I'll press Control 1, add unimplemented methods. Now I would go ahead and implement the public void run method. It's exactly the same thing. So what I'll do is I'll copy it from here so that I can change things very easily. So what we want to do is task 2 started, and task 2, as we know, runs from 201 to 299, and I would say task 2 done. So be very careful. Task 2 started, task 2 done, and it's 201 to 209. The reason why we focus on getting these things very clear is because we are going to look at the output and understand which tasks are running in parallel. So make sure that you get this right. And now what I can do here is I can remove this code. Right, this is what we moved into the task 2 class. Now, how do I execute a task 2? Here, task 2 is actually implementing runnable interface. So let's create an instance task 2 is equal to new task 2. Right. Once you create a new instance of the task 2, then you need to create a thread class. So I will need to create a thread. Thread is equal to new thread of task 2. So if I'm implementing runnable interface, after creating the instance, we would need to do an additional step to create the thread class. Once I create the thread class, then I can say thread.start, right? And to make it very clear, I'll rename it. Right click, refactor, rename, and I'll call this task 2 thread. Right, so this is the thread running task 2. And now let's see what would happen. So task 1 is kicked off, task 2 is kicked off in here, and task 3 is kicked off in here. Cool, right? So let's now see what happens. You can see that task 1 is kicked off, and even before any code inside the task 1 is run, task 2 is kicked off, task 1 is started, and even before task 2 gets started or task 1 is completed, we see that task 3 is also kicked off, and we see that 300 and all that kind of numbers are getting printed. And over here you can see all the different kinds of numbers that are printed, right? 300, 200, 117. So all the 3 tasks are running in parallel in here, and at this point task 1 has completed, and after some time task 3 has completed, and after that some time main was completed, and only after that task 2 is completed. So task 2 completed after main also has completed, right? Even after executing main, so this is the last statement in the code that we executed, right? The task 2 completed after the entire main code was completed running. This is the advantage of going for threads, right? What we are able to do, we are able to get all these 3 running in parallel. Let's say these are 3 different threads which are doing 3 different activities. then by doing them in parallel, we get a lot of benefits, because now we are making optimal use of our CPU. We are keeping it busy even when it's waiting for something for task 1 or task 2 or task 3. It has other tasks it can do. That's the biggest advantage of going for threads. In this step, we looked at how to implement a runnable interface and use that to start a thread off. We created task 2 and then we had to do an additional step. We had to create a new instance of thread, and then we were able to call the start method, and we saw that all these 3 tasks are running in parallel with each other. That's cool, right? Until the next step, bye bye. Welcome back. In this theory step, let's discuss about the different states of a thread. Let's try and run this program, and there is some output which is getting kicked off in. So what I'll do is I'll copy this output in here. This output would be useful for us when we are discussing about the states of a thread. What is a new thread, right? So when I have created this task 1, so as soon as I created the task 1, this task 1 thread is ready, but it's not executed yet, right? So we have not told it start running yet, but it's ready, right? That state is called new. The same state is present here for task 2, right? The task 2, after line 62, the thread is ready, but we are not asking it to start running. This state is called new. A thread is new when it's ready to run, but nobody has told it to start running yet. So before the execution of the start method, the thread is in a state called new. The next state is terminated. Terminated is when here task 1 is completed, task 1 is done. So task 1 thread after this particular point is dead. The same is the case with task 2 thread after the task 2 done is executed. So the threads are done executing. So new is when I have not even started executing. Terminated or dead is when I completed execution. The interesting ones are the ones in between, right? When 158 is being printed, which task is in execution? The task which would be executing, that would be task 1. Task 1 at that particular point in stage is in a state called running. It's executing at that point in time. When task 2 is printing 201, it's in a state called running, right? So that thread is running at that particular point in time. When task 2 is printing this out 201, what is the state of task 1? Is it waiting for anything? Nope, it's ready, but it's just that it is not being executed. That state is called runnable. Runnable is when I'm ready to run. I would want to do some work, but the other thread is being executed. So in here, when 201 task 2 is running, task 1's state is runnable, task 2 state is running. When 159 is getting printed, then the state of task 1 is running, because that's the one which is printing it. However, the state of task 2 is runnable. It's waiting for the chance to get execution and print the next number 202. The same thing is the case when 301 is running. When 301 is being printed by the task 3, that's main method, right? So task 3 is not really a thread, it's just the execution. So this is executed by the main method directly. So the main thread, when 301 is being printed, the main thread is the one which gets the CPU. The other two threads, which are task 1 and task 2, what are they doing? They're just waiting. They're waiting for getting the CPU. Their state is runnable. The last state is blocked. The state of a thread is blocked when, let's say, I'm waiting for an external service to respond, or I'm talking to the database and the database is slow. Then I'm being blocked because I cannot execute, because I'm still waiting for some data to come back from an external service. The other option is also when I'm waiting for some other thread to provide some data that I would need. So let's say thread 3 depends on thread 1's data. So the thread 3 is waiting for thread 1 to complete processing. In that kind of a situation, we would be in a blocked state. So the 5 states of a thread are new when the thread is created. However, the start method is not really called. After calling the start method, a thread might be in any of these 3 states: runnable, running, or blocked. Runnable is when I'm ready to run, however some other thread is running at this point. Running is when I am the one which is running, so my state would be running. Blocked is when I'm calling an external interface or a database or something like that and I'm waiting on it, or I need some data from some other thread which has not yet completed execution. So that's the state when I'm blocked. The last state is terminated or dead, when I have completed execution. These are all the different states that a thread can be in. I'll see you in the next step. We would talk about more complex topics around multi-threading. Until then, bye-bye. In the previous steps, we learned how to kick off threads, right? We learned how to implement a simple thread by extending a thread class or by implementing a runnable interface. And we learned how to kick them off either by calling the start method on instance extending the thread class, or when I'm implementing the runnable interface, I would need to do an additional step and then kick off using the start method. These were the couple of things that we discussed in the previous steps other than the state of a thread. In this step, our focus is on giving priority to these threads. Let's say I would want to give higher priority to the task 2 over task 1. How can I do that? That's what we would focus in this specific step. In the thread class, there is a method called set priority. You can set the priority on a specific task, right? So if I go to the set priority method, you would see the documentation for that. It says it changes the priority of this thread. The priority has to be in the range of max priority and min priority. What's the value of min priority? Let's check that. So min priority is 1, normal priority is 5, and the max priority is 10. This is the range in which the priority of a thread can be. By default, a thread would be given the normal priority, which is 5. And you can assign anything between a minimum priority and a maximum priority. Again, one more important thing you need to note is assigning priority is just a request. When I say a thread has priority 10, it's just a request. It does not mean that always that thread would get the highest priority. It's just a hint. The request might be honored or might not be honored as well. So let's get started with setting a priority on task 1. Let's say I would want to set a priority of 10. Let's see what would happen right now. I'm giving a priority of 10 to task 1. So you can see that task 1 has started and task 2 has completed. Task 1 has completed before task 1. Let's execute it a few times. You can see that task 1 in this situation is even completed before the task 3 has completed, even before main has completed execution. In this specific situation, task 1 has completed before task 2 and task 3. In this situation, task 1 has got real high priority. So it's completed very, very quickly, even before task 2 has got started. So in here, task 1 has got little lesser priority, but still it got completed before any of the task 3 or task 2 are completed. So as you can see, the priority is just a request, right? So what I'll do is I'll set up less priority for task 1, and now I'll give higher priority to task 2, right? Let's say task 2 thread dot set priority 10. So I'm giving higher priority to task 2 and lesser priority to task 1. Let's see what would happen. You can see task 2 started, task 1 done, and task 2 done. The priority request has not been really accepted. In this situation, also the same. Aha, for the first time, task 2 has completed before task 1. That's good. And task 1, task 2, and task 3, that's the order in which they are completed. Now it has been added to task 2 has completed before task 1. Now, if you run it 100 times, you would see that when you place a request to have higher priority for task 2, then probably half the times this request would be adhered to. In this step, the idea was to introduce you to priority. We saw that we can set a priority between 1 to 10, and we saw that priority is just a request. It's a hint. It's not really an order. So it might not be honored as well. So I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous steps, we talked about creating threads, we talked about priority of the thread, and we talked about different states of a thread. In this step, let's talk about the communication between threads. We have two tasks here, task 1 and task 2. And the task 3 is directly run inside the main method. So it's not really a thread, it's directly code which is running inside the main method. What I would want to do is I would want to have this task 1 and task 2 complete before I would want to start task 3. How do I do that? That's basically the focus of this specific step. Over here, task 1 has started. Over here, task 2 has started, right? Now, over here, what I would want to do is wait for task 1 to complete. So I would want to go to task 3 only when task 1 has got completed. How do I do that? The way I can do that is by saying task 1 dot join. As you can see, documentation says wait for this thread to die. So it waits for this specific thread to complete execution. One of the important things is task1.join method throws an exception. So I can do a control 1 and say add throws declaration. When we talk about exception handling, you would learn about why would need to have a throws in here. For now, throws interrupted exception. That's the only thing that we need to add in. So all that we needed to do was, there was a compilation error. So control 1 and say add throws. That's all that you need to do. And now we are saying task1.join. Let's see what would happen, right? So you can see that before task 3 was kicked off, task 1 has completed execution. So you can run it 10,000 times. You would always see that task 3 is kicked off only after task 1 is done. Task 1 is done, task 3 is kicked off. Task 1 is done, task 3 is kicked off. Task 1 is done, task 3 is kicked off. So that's the thing that task2.join does. What happens is only when this task is completed, the next line of code in here is executed. This is very important when before kicking task 3, I would want to make sure that task 1 is complete. Let's say I would want to check that both the tasks are completed before I go in. How do I do that? Task2.join. Oops, it's not really task2.join. It should be task2thread.join. Let's run this now. You can see now that task 3 will be kicked off only after both task 1 and task 2 are done. Task 1 done, task 2 done, and task 3 is kicked off. You can run this multiple times, and that's exactly what you would see. Task 3 will be kicked off only after both task 1 and task 2 have completed execution, right? So you can see that in multiple executions. The advantage of doing stuff in this way is because now I've kicked off task 1 and task 2. So both of them are running in parallel, and I'm waiting for both of them to complete execution. And after that, we are kicking off the other tasks. In this step, we looked at using the join method to wait for that specific thread to complete execution. The join method would ensure that at this point, when the join method is called, task 1 is completed. Only then the code execution moves forward. I'll see you in the next step. Until then, bye-bye. Welcome back. Before moving into Executor Service, in this step, we would talk about a few miscellaneous things that are important regarding thread. The first thing that we would do is we would go to JShell, look at one of the important methods which is present in thread class. It's a static method, thread.sleep. So if I say thread.sleep 1000, what would happen is the thread would sleep. It would go into a waiting state for 1 second. To make it even more clear, let's called thread.sleep 10,000 milliseconds. That's 10 seconds, right? So I'm going to press enter right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, you can see that the thread has went into a waiting state, and after at least a period of 10 seconds is when the thread get active. So that's one of the important methods whenever you would want to make your program sleep. Whenever you want to introduce a wait time, thread.sleep is a good method to do that. The other method which you can use is something called thread.yield. Now, when you use thread.yield, there might be situations where I think, okay, I'm getting a lot of CPU. I don't want a lot of CPU. At this point, I'm okay to go into a waiting state, right? So thread.yield is kind of that. So it's a request. So let's look at the documentation. So a thread.yield is a hint to the scheduler that the current thread is willing to yield its current use. Obviously, the scheduler is free to ignore this hint, right? So this thread task 1 is telling the scheduler, okay, I had enough time in the limelight, I have enough CPU, so I'm okay to give up CPU. But the scheduler can tell back saying, no, you should have the CPU, take it. So this is just a request. So thread.yield is another method which is important. It's another static method on the thread class. Having looked at these static methods, there is another important keyword that's very important when it comes to threads. That's called synchronized. Let's open up the code for one of the collection classes. Let's open up the code for hash table. As you can see in here, hash table is available from Java 1, and this approach of synchronization is also available from Java 1. You can see that over here, most of the methods have a synchronized keyword. So synchronized. So almost every method in the hash table has a synchronized keyword. Now you might be wondering why the hash table is synchronized. Let's say there is a piece of data. Let's say there is a piece of data that is shared between these two threads. Let's say these two threads share an instance of a hash table. When you put a synchronized on here, then only one of these two threads, either the task 1 or the task 2, only one of these threads will be able to execute the code in any of the synchronized methods. What I mean to say is, if there are 50 synchronized methods, at any point in time, only one of these threads would be able to execute any of the 50 synchronized methods. You have 50 synchronized methods, let's say they have 1000 lines of synchronized code, and only one of the threads would be able to execute any of these 1000 lines of code. If one thread is already executing any of these 1000 lines of code, then the other thread has to wait for the first thread to complete execution of the synchronized code and come out of it before it can get access to execute the method. That is the importance of this synchronized keyword. One of the important things to understand is synchronization would put a lot of overhead, because these 1000 lines of code will be executed only by one thread at a time, and it would make all the other threads which needs to execute that code wait for it. So the performance of the system might get affected. In recent versions of Java like Java 5, Java 8, there are more alternatives to enable thread safety. We are not just dependent on the synchronized approach. When we talk about concurrent collections, we would talk about other approaches to thread safety. In this step, we looked at three important things. One is thread.yield, which is a request to give up CPU. The second one was thread.sleep, which is a request that I would want to sleep for some time. The third one is the synchronized keyword. Once you put a synchronized keyword, then only one thread would be able to execute that code on an instance. All the other threads which want to execute synchronized code in that specific instance should wait for access, should wait for the executing thread to complete execution. In the next step, let's move on to a very interesting topic which is related to threads called the Executor Service. Until then, bye bye. Welcome back. In the previous few steps, we created threads and started running them. One of the important things that is lacking in this way of running threads is we don't have any control over the execution of the threads, right? We don't know how many threads are running at a particular point in time. Let's say I would want to allow only 3 threads to be running at any point in time. That kind of control is very difficult to establish when we allow threads to run themselves by using the start methods. The other problem is, let's say I would want to wait until one of task 1 or task 2 is complete. That's not really possible with the basic things that we can do with threads. So I would want to wait until either of task 1 or task 2 to complete. If I write code like this, then this would wait for both the task 1 and task 2 to complete, and only then execution goes here. But if I want to do things like, okay, I would want to execute line 59 after at least one of these tasks, task 1 is completed or task 2 is completed, I would want to go to 59. That's not possible in this way of executing things. And also the running of the threads is a very tedious task, right? So if I want to run 100 tasks, then the way I can do that is create all this kind of code and kick off start. Do this kick off start. There is no way of managing them as a group. And last but not the least is the fact that some of the times a thread executes a task and we would want to return this result back. That's not really possible with the things that we have talked about until now. That's where the Executor Service comes into picture. Executor Service provides facilities to do all the things that we have talked until now. It helps us to kick off multiple threads at the same time. It helps us to monitor the state of these threads, and it helps us to write logic which enables us to say, okay, if either thread 1 or thread 2 or thread 3 has completed, then that's fine. I would want to take the result of whichever one has completed first. Or you can even say something like, okay, wait until all the threads have completed execution in a single statement. So that's all the kind of code that you would be able to do with an executor service. In the next step, let's get started with the hands-on on executor service. Until then, bye-bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.